Alright, in this video we are going to go over our graphing CBA review. I'm going to go over the first few questions in each section. I'm not going to go over every single question in every single section, but I'll do enough that you should be able to do this on your own, and you can check the first 3 or 4 questions in each section. So the lines are a little bit difficult to see on the video, but if you have the companion assignment that goes with this, you should pretty clearly see this coordinate plane, first quadrant of the coordinate plane, that we're going to use for this entire first page. So what we're doing here basically, and I've given you an example problem with an example answer, is we're just describing the process for how we would plot where the points are at. All right, so if we look at the example problem for K, which is right here, we're going to move along the x-axis 5 spaces. So we're just basically moving our pencil to the 5 spot. Now some of you will draw a line, which is fine, and you'll draw that line up to the K. And then we're going to move up parallel to the y-axis until we get to that point on K. And I know some of you will also do this so we can very clearly see that our y is 6 and our x is 5. And that's basically what you're going to do on the rest of these problems. So for J, we're going to move 1, 2, 3, 4 spaces along the x-axis. And that's just us kind of tracing our pencil and saying, okay, here's our 4. And then we're going to move up in a line parallel to the y-axis. We're going to move up 8 spaces. So we're going 8 spaces parallel to the y-axis. And so you're really just kind of rewriting that sentence. You're just changing based on what your point is. So for J, our point is 4, 8. So we're moving 4 spaces along the x-axis and then 8 spaces in a line that's parallel to the y-axis. Okay. Let's do one more. So for H, which here's H over here, we're going to move 1, 2, 3, 4, 5, 6, 7, 8 spaces along the x-axis and 9 spaces parallel to the y-axis. And so that's going to give us the point of 8, 9. So my x is 8 and my y is 9. All right, and you're just going to do that on the rest of the points that are listed on problems 4 through 8. All right, let's go to the next page. So on this next page, we are given a function table. And this particular function table is horizontal. A lot of times we'll see them vertically, sometimes we'll see them horizontally. And this is pretty simple. We'll actually go through all of these just to make sure we understand what we're doing here. Because basically all we're doing is, for each of these points, we're going to write the x and the y coordinates. So this is set up horizontally, so it's a little bit strange, but it's almost like, if you can think of it turning sideways, and this is going to be our point that we're going to plot. All right, so this is what our coordinate will look like. So let's start with this first point. The x is going to be 1. Go up, and the y is going to be 2. And so you can kind of see how, even though they're going to be sideways now, but this is my point. This is my coordinate, 1, 2. All right, next point is going to be 3. X is going to be 3. 1, 2, 3 on the x. And then the y is going to be 4. And then the final point, x is going to be 5. Go up. And y is going to be 6. Now the other thing that we may be asked to do is to see if we can see a pattern in here. Because if we look at this, then clearly we can see that there is a line here. And we've talked about the fact that we've got that equation. And so each time as we go up, depending on it doesn't matter which point, the y is always one more than what the x was. And so we've got an addition, or sometimes you'll call it an additive pattern. All right, and this is a little bonus right here. This isn't actually in your instructions. It's just a little, because you may get some questions on STAR where it's asking you to identify what kind of a pattern it is. Okay. All right, number 10, first point, x is 1, y is 2. Next point, x is 2, y is 4. Final point, x is 3, and y is 6. Now on this one, it's going up by 1 here, by 2 here, by 3 here. So it's not an addition pattern, it's not an additive pattern, but you can kind of see 1 to 2, 2 to 4, 3 to 6. Well, if you're good at detecting patterns, you can kind of identify that what's actually happening here is we're multiplying by 2 each time. So the x is getting multiplied by 2. So 3 times 2 gives me 6, 2 times 2 gives me 4, 1 times 2 gives me 2. And so this is a multiplication, or, and I'm probably going to mispronounce this, multiplicative, probably mispronounced and misspelled it, pattern. But my pattern is not addition, it's multiplication. All right, and when we look in a few moments at some of our equations, we're going to see what that looks like if we're given the actual equation. All right, again, this is bonus stuff. This is not anything that you're required to do on these particular problems, but I did want to make you aware of it because on future problems you may see a question like that. All right, number 11. First point, x is 2, y is 1. Next point, x is 4, y is 2. Third point, x is 6, and y is 3. Number 12, x is 1. Now this you have to look a little bit closer because the point is not on the 1 or the 2, so I'm going to say y is 1.5. If you wrote 1.5, that's okay too, if you wrote it as a fraction. All right, next point, x is 4, y is 6. Final point, x is 6, and y is 9. Number 13, first point, x is 1, y is 3. Next point, x is 2, y is 5. Last point, x is 3, and y is 7. All right, on to the next section. So in this section, we're actually given the equation, and we're given an input-output table or a function table, and we have to, for each of these inputs, we have to substitute in for x. Remember, our input is our x, and our output is our y. So basically what I'm going to do for each of these is I'm going to rewrite the problem y equals 0.5 times whatever my input is, whatever my x is. So for this first one, y equals 0.5 times 11. So I'm going to go and set up that multiplication. 5 times 1 is 5. 5 times 1 is 5. I have one number to the right of the decimal that I'm multiplying, so my answer needs to have one number to the right of the decimal. So my first output is 5.5. Right, next one, y equals 0.5 times, and my input now is 14. So again, just going to go 14 times 0.5. 5 times 4 is 20. Carry my 2. 5 times 1 is 5, plus 2 is 7. One number to the right of the decimal that I'm multiplying, so my answer needs to have one number to the right of the decimal. I don't need to write the 0.0 because that doesn't change the value, so I'm just going to write it as 0.7. And then my final one for number 14, y is 0.5 times 23. And again, just subbing that last input. So I do 23 times 0.5. 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus 1 is 11. One number to the right of the decimal, so my answer is going to have one number to the right of the decimal. And so I get 11.5, or 11 and 5/10. And we're just going to do that all the way down. All right, I'll do one more. I'll do number 15, and then I'm going to let you guys complete the rest on your own. So, first one, y equals 3 and 5/10 times, my first input is going to be 17.2. So I'm not going to do an X, I'm going to do a dot. Let's go ahead and label these as X and Y. Alright, so I'm going to have 17.2 times 3.5. 5 times 2 is 10, carry the 1. 5 times 7 is 35, plus 1 is 36. Carry my 3. 5 times 1 is 5, plus 3 is 8. Placeholder. 3 times 2 is 6. 3 times 7 is 21. Carry my 2. 3 times 1 is 3, plus 2 is 5. 0 plus 0 is 0. 6 plus 6 is 12. Carry my 1. 1 plus 8 plus 1 is 10. Carry my 1. 1 plus 5 is 6. Two numbers to the right of the decimal. So my answer needs to have two numbers to the right of the decimal. So my first output is 60.2. And off camera, I'm going to pull out my calculator and make sure I'm not making any computation errors here. Because I know how much you guys love to catch it when I make a computation error on these videos. Alright, I'm good on that one. Alright, next one. Y is 3.5. And my input is 21.5. So once again, set up my multiplication problem. 21.5 times 3.5. 5 times 5, 25. Carry my 2. 5 times 1 is 5, plus 2 is 7. 5 times 2 is 10. Placeholder. 5 times 1 is 15. Carry my 1. 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6. 5 plus 0 is 5. 7 plus 5 is 12. Carry my 1. 1 plus 4 is 5. 1 plus 6 is 7. Two numbers to the right of the decimal that I'm multiplying up here, 1 and 1. So my answer needs to have two numbers to the right of the decimal. So my output would be 75 and 25/100. Look at me, 2 in a row. All right, final one for number 15. Y equals 3.5, and then my input is 33.5. So on each of these, you see I'm just subbing in whatever my input is for X, rewriting the equation. Rewrite the equation, that way you know exactly what it is that you're doing when you set up the problem. All right? I'm going to run out of space here if I'm not careful. All right, so 33.5 times 3.5. 5 times 5 is 25. Carry the 2. 5 times 3 is 15, plus 2 is 17. Carry my 1. 5 times 3 is 15, plus 1 is 16. Write down my placeholder. 3 times 5 is 15. Carry the 1. 3 times 3 is 9, plus 1 is 10. Carry my 1. 3 times 3 is 9, plus 1 is 10 again. 5 plus 0 is 5. 7 plus 5 is 12. Carry the 1. 1 plus 6 is 7. 1 plus 0 is 1. 1 out there at the end. Two numbers to the right of the decimal, so my answer is going to have two numbers to the right of the decimal. And so my output is 117 25/100. Double check my math. Good. And that's what you're going to do on the rest of the page. So for each of these, you're just substituting whatever the input is for the X, and that will give you an output. When you see a function table like this and you see input-output, it's not a bad idea at all to just mark X, Y everywhere you see, X where you see input and Y where you see output. Not a bad idea at all. Just mark them all up. That way it's very easy for you to remember that you're going to substitute these numbers in for x and then do your calculations. All right, on to the next section. So the next section is similar to when we were finding those points, except this time instead of individual points, we've got lines that we're looking at. All right, but same concept. We're given the number of cartridges, so that's here at the bottom, and this is basically our input or our x, and then this is our y or our output, because here's number of pages right here, and here's number of cartridges right here. All right, so our x-coordinate, if x is 2, I need to figure out what the y would be. So I look on the line, x is 2, and y looks like it's pretty close to 1,500. Oop, not 15,000. It looks like it's pretty close. I know it's probably hard to see on the video because the lines are a little bit faded, but it looks like it's pretty close to 1,500. All right, if x is 5, looks like y is going to be, looks like right on the line for 3,500. And then if x is 7, now this top line is not marked. However, if I look at the values on the side, each line is going up by 500. So this top line would be 5,000. And so if x is 7, y is going to be 5,000. And that's what you're doing on the rest of these. So for each one, you're just saying, okay, if x is 1, what's y going to be? And I would go ahead and trace a line up, especially since these lines are a little bit challenging to read. I'm not going to go through every one on these because I think you guys should be able to do these pretty easily. Okay, let's go on to the next one. Now on this particular question, we had two of these questions, similar questions on the benchmark, and we had trouble on these because we did not read the directions carefully. So I'm going to read the directions now, and hopefully you will follow along with me. The ordered pairs for the points on the coordinate plane satisfy the equation y equals x plus 1. Complete the table. So that's my instruction. Complete the table to show the other. Now I have put this in bold and underlined it, but I'm going to circle it anyway. The other points that satisfy the equation y equals x plus 1. So what they're telling us here is these points go with y equals x plus 1. All right. Now what I need to do is complete the table. Now if you look at this table, this first point is 0, 1. 0, 1's not on this table. The second point is 1, 2. 1, 2 is not on this table. And the final point we're given is 2, 3. Well, that's not on here either. So this is the example problem that I've given you, and you see we've got 3, 4, 4, 5, 5, 6, and 6, 7. Well, all of those satisfy y equals x plus 1. Because for this first point, if x is 3, then y is going to equal 4, which is what we have right here. So what we're going to have to do on the rest of these is we're going to have to fill in points that will work with this equation. Now here's the interesting thing. There's an infinite number of possible points that will work. All right, now I'm going to keep it pretty simple, and I'm just going to pick it up where the points kind of are left off. But there are a lot of different answers that could be in here. All right, we'll talk about, though, what each of those answers all have to have in common. All right, so let's go ahead and go down to number 15. It's the same question. The only difference is we're dealing with a different equation now. So I'm going to go ahead and underline ordered pairs too. And coordinate plane. All right, so on this one, we're given the points 0, 2, 1, 3, and 2, 4. Now I cannot put these in this function table because I've already used those points here. It's asking me for other points. So just like up here, where the points it gave me were not in the function table, the points I come up with can't be any of these. Now what I'm going to do is I'm just going to pick the next x input. So they started with 0, then 1, then 2. So I'm going to pick 3 as my first input for x. So if x is 3, then 3 plus 2, so y is going to be 5. Now if I really want to get slick, I could actually plot this point and see that that works on the line. And there's absolutely nothing wrong with doing that, just to make sure you've got things in the right spot. And I'm going to go ahead and just do 4, 5, and 6. We'll talk about if you choose to do some different numbers, you can, but what all those numbers need to have in common. So if y equals 4 plus 2, because my x is going to be 4, then y is going to equal 6. So I'm going to plot 4, 6, still on my line, so I'm still good. If x is 5, y would equal 5 plus 2, and y would be 7. So my point would be 5, 7. Still on my line, so I'm still good. All right, my final point, if y equals 6 plus 2, because again, I'm inputting 6 for my x, and y is going to equal 8. So my point is 6, 8. And that's on the line. So that works. Now you may have different numbers in for x, but whatever number you have in for x has to be 2 more, your y needs to be 2 more than whatever your x is. So here, 3 to 5, we added 2. 4 to 6, we added 2. 5 to 7, we added 2. 6 to 8, we added 2. If you want your x to be 1,478, that's fine. Your y is just going to have to be 2 more than that, so it'd be 1,480. Because if we do y is 1,478 plus 2, then that y is going to be 1,480, because we subbed this in for x. This is our x right here. All right. Now this is an addition pattern, because again, the equation is adding 2 each time. So just like we talked about before, this is an addition pattern. All right, let's do number 16 because it's a little bit different. So number 16, same instructions. So ordered pairs on the coordinate plane. Satisfy the equation y equals 2x. We're going to complete the table. That's my action. That's what I'm doing. In fact, I'm going to bracket that. Complete the table to show other points that satisfy the equation y equals 2x. So again, we're given 3 points to start out. All right, so our first point is 0, 0. Second point is 1, 2. Third point is 2, 4. All 3 of these will work for y equals 2x, but remember, I cannot put these into the table. I've got to come up with other points. So I'm going to do what I did above, and I'm just going to choose the next 3 numbers for my x input. So I'm just going to go 3, 4, 5, 6. Doesn't matter what numbers you pick, you're just going to have to plug them into the equation. So for the first one, y equals 2x, so y is going to equal 2 times my first input, which is 3. 2 times 3 is 6, so y would be 6. So that's going to be 3, 6. And I'm going to draw my line again just to check the first couple of answers, because once we get to a certain point, we're not going to be on the graph anymore. All right, next input is 4. So y equals 2x, so y is going to equal 2 times 4. Summing 4 in for my x. 2 times 4 gives me 8. So my y is 8. 4, 8 is on my line, so I'm good. Next, x is going to be 5. So 2 times 5 is going to give me 10. 5, 10, still on my line, so I'm still good. And now my final point, I'm going to substitute 6 in for x. So since y is 2x, 2 times 6. So y is going to be 12. Now here, I can't plot 6, 12. I can go on 6, but it only goes up to 10. So I can't get it up to 12. But each time, if you look, my x is being multiplied by 2. So this is that multiplication pattern. Multiplicative pattern that I can't pronounce. Or spell, apparently. Alright, I'm going to let you do the last one on your own. I'm going to get you started on it, but I'm going to let you do the last one on your own. So the points we're given are 0, 0. We're given 1 and 0.5. And we're given 2 and 1. So these are the 3 points that are plotted here. Remember, we cannot use these in the table because we need other points. All right, same instructions. Ordered pairs for the coordinate plane. Satisfy the equation y equals 0.5x. We're going to complete the table to show the other points that satisfy y equals 0.5x. Now, your choice on what numbers you want to use. As you saw what I did up here, that's probably what I would do down here. I would just probably pick the next 3 numbers in the sequence. Okay. All right. That'll do it for this section of the review. The other sections of the review will be up later today. If you have questions, ask me in class tomorrow. I'll see you guys in the morning. Do good work.